I will be explaining a 2 to 4 decoder and how to simulate it using EDA Playground. First, let's understand the 2 to 4 decoder. A 2 to 4 decoder takes a 2-bit binary input and generates a 4-bit 1-hot output. The term 1-hot means that only one of the output bits will be set to 1 while the rest are zeros based on the binary input. For example, if the input is 0, 0, the output will be 0, 0, 0, 1. Only the least significant bit is 1. You can see the last bit is only 1, the others are 0. For every input, only one bit will be 1 and others are 0. If the input is 0, 1, the output will be 0, 0, 1, 0. Now let's move on to the software I will be using for this demonstration. I am going to use EDA Playground, which is a web-based platform that allows us to write, compile and simulate System Verilog code online. To access the website, search for EDA Playground on Google and click on the first result. Choose your Google account to log in. After login, you will notice there are two sections on the site, one for the design code and another one for the test bench code. The design section is where we will write the code for our 2 to 4 decoder, and the test bench section will be used to test our design by simulating different inputs. Before writing the code, select a simulation tool. I'll choose Icarus Verilog 12.0. After selecting the simulator, also enable the Open EP wave after run, which is used to visualize the output waveform. This will help us to see changes in the output based on the different inputs we apply to the decoder. Here we have test bench code and a design code. First I will explain the design code. In this code we begin by defining a module named decoder underscore 2 to 4, which is our 2 to 4 decoder. The module takes two inputs and produces a 4-bit output. The keyword input logic 1 is to 0 in means that the input is a 2-bit wide binary value, and output logic 3 is to 0 out means that the output will be a 4-bit wide value. Inside the module, we use an always comp block, which means the logic inside will be evaluated whenever the input changes. The always block is like a loop, and the comp means combinational circuit, since the decoder is a combinational circuit. The main part of the code is the case statement, where we define what the output should be based on the input. If the input is 0, 0, we will mention that as 2-B00, since it's a 2-bit binary value, and we set the output to 0001 using out equal to 4-B0001. Here the 4-B is means 4-bit binary value. Similarly, if the input is 01, we set the output to 0010 and so on for the inputs 10 and 11. We also include a default case which handles any unexpected inputs by setting the output to 0000, though this case won't normally occur in this 2 to 4 decoder. Moving on to the test bench code, we begin by declaring the inputs and outputs that we will use for testing. The test bench is used to apply inputs to the decoder and check the output. We instantiate the decoder underscore 2 to 4 module using the name DUT, which stands for design under test, and connect the input and output from the test bench to the decoder. Next, we have an initial block that creates a VCD file for viewing the waveform. This allows us to save the simulation data, and we use the $dump file and $dump variable command to generate the waveform file named waveform.vcd. The dump variable is used to dump all the variables used in the test bench. In the stimulus block, we apply different binary inputs to the decoder one by one. For example, we start by setting the input to 0, 0, wait for 10 time units using the #10 command, and then change the input to 0, 1 and so on. Testing all four possible inputs after the final input, we use $finish to end the stimulation. Then we close the module by using end module. Now we will run the code and see the output. The output will be as a waveform because we use EP waveform tool. Now let's briefly look at the output. After running the simulation, we can see the waveform output. The input changes through the values to their corresponding output. This confirms that the 2 to 4 decoder is working correctly. as each input activates only one output bit at a time, which is what we expect from a 1 hot decoder. Thank you for watching.